Welcome to CE 402, Environmental Engineering 2, Module 6, Part 4. In this session, I am going to discuss about the anaerobic sludge digestion tanks. That is, it is a digestion tank constructed with a RCC and a cylindrical section as that similar to that of a settling tank, and the bottom is hopper type, and it may be covered with a lid that is maybe of fixed or floating type, and the latter makes the operation more effective, that is the floating type, as that same as that of in the biogas chamber. The weight of the cover is supported by the sledge, and the liquid force between the tank wall and the side cover provides a good seal. As the gas rises inside the tank, the float will rise. And the raw sludge is plumped into the tank where it is seeded and digested, seeded with the digested sludge, and it will be mixed inside the tank, and it will undergo the anaerobic digestion, and it will form gases like methane and carbon dioxide. Majority of gas will be of methane, and then the carbon dioxide, nitrogen and hydrogen sulfide will also be formed, and the gases rises out of the digesting sludge, moves along the ceiling of this floating cover and collects in the gas dome. And the cover can float on the surface of the sludge between the sludge blanket and the landing brackets of overflow pipe. The rollers are provided at the end of this scrapping mechanism in order to avoid the binding of this sludge blanket to the side walls of the anaerobic digestion tanks. The digested sludge which settles down the bottom of the tank, which can be removed by the hydrostatic pressure arrangement. Periodically, it should be removed from the tank, and the frequency of removing should be once in a week. And to maintain an optimum temperature, the tank is generally provided with the heating coils in order to enhance the bacterial action. And the supernatant liquor, the part of the tank content lying between the scum and the sludge, is withdrawn at an optimum level through a number of withdrawal points located at different elevations of the tank, depending upon the quantity of sludge that is feeded into the tank. And as it is high in BOD and suspended matter contents, it is sent back to the incoming raw sewage for undergoing retreatment. And the scum formed at the surface get broken up by recirculating the flow by mechanical rakers called scum breakers. The amount of sludge gas produced varies between 0.014 to 0.028 meter cube per capita, with 0.017 meter cube being quite common. The gas produced contains 65% of methane, and with a calorific value of 5,400 to 5,850 kilocalorie per meter cube, and 30% of carbon dioxide, and the balance 5% of nitrogen and other inert gases. It resembles natural gas and may be used as a fuel for cooking. This is the schematic representation of a floating covered digestion tank. You can see the gas dome at the top of the sludge digestion tank. You can see the digested sludge trough arrangement, and the supernatant collection troughs you can see by the sides of this sludge tank, and the gas will be collected through these gas vent pipes, and you can see the raw sludge inlets and recirculation discharge pipes inside this sludge digestion tank, and rakes are provided to the sides of this tank for breaking or in order to avoid the binding of this scum or the sludge blanket to the wall of the sludge digestion tank. Then this can be classified into three types, that is conventional or standard rate digester, then a high rate digester, and a two-stage digester. The conventional or standard rate digester is shown in figure. This is this is a type of digester in which the quantity that can be digested will be very low, and the sludge thickening process is also very slow. And you can see the three different layers are formed inside the these sludge digestion tanks. Mainly three layers, and you can subdivide it into digested sludge and active digesting, then supernatant layer, and a scum layer, and a gas storage. And due to these different layers of this sludge, the proper mixing is not done, so the digestion process will be very slow, and it will be it is not affected if the quantity of sludge is very high. And then the high rate or completely mixed single stage digester. In this single stage digester, we are providing the mixing properly, that is by mechanical mixers. Then if the sludge is mixed in a proper manner, then the raw sludge will be mixed with these digested sludge, and the bacterial action will be complete during this mixing action. And the detention time for this will be 10 to 15 days. And the digester is usually heated to operate in a mesophilic range of temperature, that is 20 to 40 degrees centigrade. And the solid concentration will be about 6%. And it is a single stage digester. The later is also a single stage digester, and the next one is a two stage digester, in which the first stage is of high rate one and the second stage is of standard one, that is a slow rate one. And you can see the figure, that is after completing the first stage, the sludge is fed into the normal stabilization or second stage sludge digestion tanks, and then the supernatant, that is the effluent collected after this second stage, can directly disposed of into the surface water or streams, etc. Then the advantages of two-stage digestion. It does not allow short circuiting of the sludge as it is possible in the case of single-stage digestion. Then the construction and working of the tanks is relatively simple, and the digestion efficiency is increased, and large amount of scum formation is avoided. Then supernatant liquor obtained from the secondary digestion tank is of better quality, then it can be disposed of into the surface water itself. And total cost is less than two single stage digestion tanks, and secondary sludge tanks acts only as settling tank or sedimentation tanks. Then advantages of anaerobic digestion, that is methane recovered can be used as an alternate for fuel source, and it will reduce the production of landhouse greenhouse gases when otherwise these untreated sludge is disposed of on the landfill or used for the landfill, which will broken down anaerobically to release methane into the atmosphere. This will be a pollution causing factor. And reduction in volume of the sludge and improving dewatering characteristics of the sludge makes it easy to dry, and it reduces the odor and fly problem, and low operating cost since energy is not required to supply oxygen being in anaerobic process. And the disadvantages are accumulation of heavy metal and recalcitrant contaminants in the sludge will happen, and a narrow operating temperature control range that will also affect the efficiency of the digestion process. And when heating is to be provided, safely handling is required with the electrical grid based on the heat management. That is, for heating the tank, we are using the electrical coils. Then the sludge conditioning. This sludge conditioning is given to the sludges after digestion in order to enhance the dewatering process of the digested sludge. This can be done by either chemically or by heat treatment. And the affinity of the water to bind with these sludge is very high, and we have to break this affinity, then only the dewatering process will be accelerated. And the chemical conditioning results in coagulation of solids and release of the absorbed water. The conditioning is used in advance of vacuum filtration and centrifugation. And after this conditioning, if the sludge is given for the centrifugation process, then the process will be very efficient. And the chemicals used for these purposes are perchloride, lime, alum, and organic polymers. And the dosage can be determined by using laboratory tests. The sludge, which is difficult to dewater, require higher doses of chemicals. And the heat treatment of sludge in both the stabilization and conditioning process. This involves heating of sludge for short period, that is 30 minutes under pressure, that is 1 to 1.4 meganewton per meter square. And the temperature is kept in the range of 140 to 200 degrees centigrade. And the treatment coagulates solids, break down the gel structure, and reduces the water affinity of this sludge solids. As a result, the sludge is sterilized, deodorized, and dewatered readily on vacuum filter or filter process or centrifugation process. And the heat treatment process is most applicable to biological sludges that may be difficult to stabilize or condition by other means, that is by using chemicals. The high capital cost of equipment generally limit its use in the larger plants, that is the heat conditioning, that is sludge conditioning using heat treatment. I think you understood the session about this anaerobic sludge digestion and sludge conditioning. Thank you for listening. See you in the next class.